All right. What about the interval? What is that? Interval notation just means left edge, right edge. So let me clean this up a bit for us. Here, let me just make it bigger. So the correct answer, I'll just put it right here on the number line, then we'll do the interval. So where was it? So it was x less than -5. So it's a parenthesis there. Parenthesis at -5, and the shading went that way, right? So that was our number line answer. Now, how do we turn that into what's called interval notation? Interval notation just means what chunk is shaded up there. They want you to tell them the chunk of shaded numbers, and by going left edge, comma right edge. Left edge, comma right edge. So this is the left edge, and the -5 is the right edge. So what do I mean this is the left edge? There's an arrow there. It's like going forever left, right? That's shading. See the arrow? Here's the answer was, it's hard to see. The shading goes forever left, like my thing does. Forever left. How do you say forever left?
Infinity.
Yeah, negative infinity, huh? Because negative numbers are to the left? Yeah, so that would be negative. If by the way, if you have something go forever right, that's regular infinity. Forever left, those are negative numbers, negative infinity. Yeah, so we would say parenthesis, negative infinity, comma, -5. Because that's the left edge, right edge of the shading. When we say that answer, we're saying the shading goes from negative infinity up to -5. Left edge, right edge of the chunk of shading. So that's what interval notation means, left, comma, right. The order matters. You can't swap them. It's got to be left to right. So the shading goes from negative infinity up to -5. And there's parenthesis, so we use parenthesis. If that had been bracket, I would put a bracket. You never put a bracket by an infinity because you can never be right on infinity, huh? Remember, the bracket means you're straight on it. You're just around it. You might go to the doctor's office and say, I waited forever. But you didn't really wait forever. You just got close to forever. It's a parenthesis. Right? All right, how about this one? Try, so we got the answer. The answer is D. Can you take that chunk of shading now and write an interval for that? Left edge, right edge. Left edge, comma, right edge. Can you write that for D? Write an interval. I'm assuming they want the same thing. It's just off our screen. So for D here, this chunk, left edge, right edge. The left edge is -11. The right edge is regular infinity, huh? So it would be, bracket. And since we have a bracket at -11 here, I need a bracket when I write my interval. But the infinity just gets a parenthesis. So you can have a bracket on one side, parenthesis on the other, which we do on this case. Bracket at -11 means straight on -11 up to infinity, left edge, right edge. Is that good? Questions on those two? Yeah, it's because it's infinity, and we always put parentheses. It's either bracket or parentheses. You never put a bracket next to infinity, because you can never be straight on. Bracket means you're straight on. That's why it's got the straight edge to it. You're right on the number. You can never be right on infinity. Okay, so number 3 there. They're right here. Let me make it a little bigger for you. They're writing a statement there, so it's -3, and then they're going like this, like that. First off, they're saying it kind of backwards. I mean, do you know what I mean? Like the -4 is really the smaller number, right? Just look at all the number lines. Here's -4. Well, I guess they're not showing -3, but you know that -4 is smaller, right? If this is 0, -3 here, -4 is the smaller number. So I think I'm going to turn the whole thing around. It's just they're just trying to write it weird to see if they can fool you. I would just turn that entire thing around. I don't like this is actually the smaller number, more negative, right? Like debt, like I was talking about, it's more in debt. So just grab the whole statement and turn the entire thing around, including the symbols and everything. I think it'll be easier to deal with. So -4, turn that. You got to keep the bar next to the -3, but I turned all the symbols, the whole thing. That's the same truth. That's saying the exact same truth, right? You can always turn the whole thing around. You see what I mean? How do I know that's saying the same truth? Well, the x is on the wider side of the -4. The x is on the wider side of the -4. The x is on the narrow side of the -3. The x is on the narrow side of the -3. See how it's all the same relationships? Yeah.
It's a positive 3 and it's a negative.
Oh, thanks. We still want to turn it around, but thank you. It's a positive regular 3. Thank you. But nevertheless, we want to turn it around. Good to there so far? So you don't have to do that, but I think it'd be easier for you. Just turn it around, okay? And now, what are they really saying? Well, that x, remember what we're shading when we shade something is we're shading x. So whatever x is, that's what we're shading. What is x? It's between those two. It's between those numbers. So it's between -4 and +3. Like that. And I did. Why did I do a parenthesis? Because there's no bar there, but there is a bar there, so bracket on that edge. That is x. So remember, what you're shading is the x. The x, the shading, is between -4 and +3. So which graph is that? C. Yeah, it looks like C. C. And then the interval notation, I mean, that's pretty much it. It's just parenthesis, -4, comma 3, bracket. That's the left edge, right edge, huh? Does that make sense how I did that? Let's compare. So x was sitting in between two numbers. So the shading, the x, is in between. Whereas on these two, there wasn't like two numbers around the x, were there? So x was just one side or it was the other side. See the difference? So when there's two numbers with x in the middle, the shading is just the chunk between those numbers. But when there's, right, which is number 3, the shading is just the chunk between the numbers. But in number 1 and 2, there's not two numbers. There's just one number, so shading just goes one way or the other, forever. Always to infinity, negative infinity, or regular infinity. Good. Yeah, domain and range, it's kind of a weird thing. It's really not the most important thing in the world. But what it is, it's just the width coverage and the vertical span, the horizontal and vertical span. Let me draw on here and I'll make it clear. So domain means like how far left, how far right does the graph go? Like if you were a little person here walking around back and forth on the x-axis, how far left could you go? How far left could you go and you'd look up and see graph? How far right could you go and you'd look up and see graph? Well, it looks like forever in both directions for the domain, right? You could go left because that arrow, see that arrow saying up and left forever? And this arrow saying up and right forever? So therefore, if you're the person walking around on the x-axis, you can go forever left, forever right for the domain. So they want me to, see how they're saying interval notation? Right here, interval notation. That always means parenthesis, and make that clear for you. That always, whenever they say interval, they mean parenthesis, left, comma, right. Or brackets, if it's straight on the numbers. But it always means the two numbers, left edge, right edge. So for the domain, what's the left edge? What's the right edge? Negative infinity, regular infinity. So negative infinity, regular infinity for the domain. I don't know why they have that second option. Domain is, no, it's just A. Negative infinity, positive infinity. Okay, and now range is the up and down. So you know how domain was the sideways. Range is the up and down. So we just say, okay, how far up, it's kind of a weird arrow there. How far up, how far down, that's called range. How far up and down does the graph go? How far up and down does the graph go? So again, this would be like if you're a person, but this time you're a little person that can walk on the wall here, walking up and down the y-axis. How far up, how far down can you go and see graph? And instead of left, right, we're gonna give the range as bottom, comma, top. And it has to be in that order. Lower number has to come first, so bottom, then top, just like left, then right. So how far, so if you're a little person here, walking up and down on the y-axis, how far down can you go and you would look over and see graph? Well, to 0, huh? You can't go below, anything below 0, the graph doesn't go below 0, does it? You with me? We're talking y-axis now. So the only difference between the domain and the range is x-axis or y-axis. It's how the sideways coverage, now we're doing the vertical coverage. So how far up and down? So how low does the graph go? Down to 0. That's the it doesn't go to negative infinity, right? There's no piece of graph that just like keeps on going down. Some will, other graphs might. This one doesn't. This one stops right here. This is as low as it goes. So that's 0 in the bottom, and the top goes up forever, huh? To infinity. So the it'd be 0 parentheses 0 comma infinity. Oh, wait a minute. I see. They only give you one of them that's interval. See, this one says here, interval notation. So that would be, oh, and I got to put a bracket on the 0. Do you see why I need a bracket on the 0? Because it's straight on the 0. Huh? It hits this straight on. It doesn't just get close to a height of 0. It gets it right on, doesn't it? This graph lands, it's from 0 straight on to infinity, right? So we have to put the bracket on the 0 because we're straight on the 0. We're not just close to it. We're not just around it. We're straight on it.
So it always goes from bottom to top?
Bottom to top. Yeah, it's got to be that order. Let me write that. Range is always bottom, comma top. Just like domain was left, right, range is bottom, top. Parentheses or brackets, as the case may be. Is that good? Let me make sure. So don't be fooled by their other options. Always do the one that says interval notation. They put it on A there. Down here they put it on the B option. I don't know why. But don't choose the other one. Always do the interval notation. I don't know what they're trying to do there. It's kind of weird. We good there? Does that make sense? So the width coverage is domain. Left, comma right. The height coverage, vertical span, is the range. Left, bottom, comma top on that. Okay, so yeah, what do you think? You want to try that? So try the domain first. So that'd be the width coverage, right? Left edge, right edge. Try that. Give you a second to get that. So what's the so the width coverage is the domain, and it means and you can write all this on your 3x5 card, for the exam next week. Left edge, comma right edge. So how far left does the graph go? Well, like right here, which looks like 1, huh? And the right edge looks like what, 7? You know what I mean? Like this is the furthest left, that's the furthest right. Domain, then always do the interval one. Now they put that down in B. I don't know why they're doing that. So never do the curly bracket one. How about that? Never do the curly bracket one. That's what I'm noticing. So this will be left edge 1, right edge 7. Brackets on both because it hits 1 straight on and 7 straight on, doesn't it? That's the width. That's the domain. You okay there? And then the range, the up and down, how low, again, that's bottom, so range, here, do this one. Never do the curly bracket one. The range is always bottom, comma, top. Can you tell me now, and we're talking about heights, right? Bottom height, the y-axis. It's a person here walking around up and down on the y-axis now. Spider-Man or something, just walking up and down on the y-axis. So what's the bottom? Well, I'm touching it right, that's the bottom, huh? But we don't say 4, do we? It's the bottom height, -2. Tracking with me? So this is the bottom, which is at -2, and the top? +4. So that would be, and brackets on both, -2, come 4, because it hits those straight on, doesn't it? Goes all the way down to bottom of -2, top of +4. Domain and range. Is this good? How you guys doing? Is this okay? Questions I can answer? All right, I'll move. Okay, so try that one. Same thing, domain and range. Okay, so what is the domain of that function? And that's if you're like here, you know, walking around on the x-axis. How far left, how far right? Why does that picture look so weird? Looks like that person has a tail or something. Anyway, whatever. So domain, so we're talking about left edge, right edge. So how far left? It goes from 1 to infinity, huh? Is that good? Bracket on the 1. Because he hits the 1, this is a solid dot straight on the 1 to infinity on the right. So it goes from 1 to infinity. Is the domain, that's the sideways. How about the up and down now? Let me let you do that real quick. Do the up and the down, the range. So it's going to be bottom, comma top, just like this was left, right. So what's the bottom? 3, and it goes up to infinity, huh? So bracket 3 to infinity. Again, you're not doing the curly, I don't know why they even give you this curly bracket option. We're just doing those. This working? You okay? Questions? All right. So what's going on here? They're giving me what's called a piecewise defined function. That just means they're giving me the function in pieces. There's 2 pieces. They're basically saying you do the graph 3x plus 7 when x is less than or equal to 0. But you do the graph 1/4 x plus 1 when x is greater than 0. So you do different graphs in different sections is basically what it is. It's 2 graphs pieced together. One graph in one territory, another graph in another territory. So before we dive into either one of those, you know what I think we better do is just review. How do you graph something like, I don't know, 2x plus 3? Let's forget about all the piecewise and territories and all the fancy stuff. Let's first make sure we're good. What if somebody just says, hey, graph that? Give me a picture. What does that look like? Y equals 2x plus 3. Does anybody remember how to graph something like that? There's a certain spot you start on. Start on the 30. Yeah, that number off to the right. Yeah, that number off to the right is your starting number, exactly. And that's always in the middle line. So it's going to be, in this case, up 3 in the middle. If that was a -3, I would go down 3. So I mean 1, 2, 3, like that. Boom, 1, 2, 3. There's my first dot. I just need one more dot now, and connect the 2 dots, you'll have the line. It's going to be a straight line. Okay, so it's always a straight line when x and y are regular, without it. Like if this was x squared or y cubed or something like that, then that's when you get curves in graphs when you have higher powers. You just have regular x, regular y, going to be straight line. We call those linear because they're aligned. Their pictures aligned. So since it's aligned, you only need 2 dots, huh? 2 dots connected, you got it. Whereas if it's curved, we would need a lot more information. So anyway, so it's a straight line. First dot is whatever that number is off to the right. When y is alone, and y is alone, so that's good. And then what do we do from there? Remember the slope thing? Yeah, good job. 2 over 1. Yeah, that's the slope, right? That's rise over run. We did like one of these or something, didn't we? Anyway, so rise, run. So that means from this dot you go up 2 over 1. There it is, and then just, connect the dots. There's our line. So you remember how to do that? Is that good? So that's graphing. We're going to need to do that in certain sections of the graph. That's what we're going to basically need to do. So there's an equation for that one. Let me give you one to try. So let's try. How about graph y equals -3x plus 1. So try that one. So draw yourself a little axis system. Find your starting point, and then do your slope thing. Your first dot and your second dot. So where's our first dot? Start on this one. This is up 1, always in the middle. That first dot is always on the y-axis. It's straight. They call that the y-intercept. mx plus b, that's the b. Remember that mx plus b thing? That's the b. So up 1. Boom, right there. At positive 1. There's our first dot. And then from that dot now, not back to the origin, but now from this dot, we march from our first dot to our second dot, and that's going to be according to the slope, -3/1, a little trouble there, rise over run. So I'm going to rise -3. How do I rise -3? Down 1, 2, 3, and then over 1. Yeah, when you rise negative, you just go down, huh? So down 3 over 1, connect the dots. There it is. I went down 3 over 1. Connect the dots. We got the line. Is that good? Is that making sense so far? Now, what they're going to do is they're going to take that information and they're going to say, hey, I only want you to graph this thing for x is greater than or equal to, let's say, 0. Greater than or equal to 0. That's what they're going to start doing. They're going to start saying certain graphs, certain territory. What do they mean, greater than or equal to 0? Well, this is the x-axis, right? This is the y. So we're talking about the x-axis. They're saying, if you're a person walking around back and forth on the x-axis, I only want you to graph when you're in places greater than or equal to 0. Well, where's that? Well, this is 0 right here. Let's say 1, 2, 3, 4, 5. So they mean we only want graph from here over. So what does that mean? That means get rid of all this part. Just start here and just this. That's all I want. Does that make sense how you would do that? I took just a piece of it, you see. That's what we're about to do. And we're going to do that for 2 graphs and piece them together. They'll connect up in the middle. We'll have one totally different graph to the left, and then this graph to the right, and connect them in the middle. And they might not connect. They might hit at different places, or they might connect. So that makes it, get the big idea? So that's what we're doing. That's about what we're going to do. So they're going to give us a condition. They'll put this over on the right side. They'll say, this equation only when x is greater than or equal to 0. And this other equation in the other zone. You're always thinking about the x-axis and where you're at. If you're 0 or bigger, greater than 0, then you're doing this equation, that formula. And if you're somewhere else, you have a different formula. So it's different equations, different formulas in different sections of the x-axis. That's what we're about to do, piecewise. So, okay. So with those tools, we're ready. So, so they're saying, do this equation for x values less than or equal to 0. Do this equation for x values greater than 0. See what they're saying there? Different equations in different zones. So how are we going to do that? Well, you know, having the technique we just did was great and all, but I think it'll be easier for you. Can you see that? Okay, yeah. I'm going to go to a fresh screen where we have more room. And I think it'll be easier for you if we just make a table. So let me do that. So I'm going to do an XY table for just for this first one. And I'll do another one for that one. Okay, and they're telling me what is, F, I should say this, F of X, that's just Y. Do you guys know that, I don't know if we've said that before or not, function values are Y. That's by common agreement in the math science world. They just said, hey, we're going to make, when we're doing graphs, we'll make them function letters, those are Y. They just agreed. Like driving on the right side of the road in North America. We just agreed. Right, it's just common agreement. So just know that that's just by agreement. So function values are Y. So that's your Y there. So this is Y equals 3x plus 7. And I'm going to, that's a line, right? These are both lines. And they're going to, you can see all the different options. You know, there's 2 different lines. We just got to find, you know, which 2. Okay, so how do we do it? Well, I'm only going to plug in X values that I'm allowed to plug in. What am I allowed to plug in? For this function, I'm only allowed to plug in X values that are less than or equal to 0. So I could put in 0, and I could put in what else? Like -1, or -2, or -3, etc. I only need 2 dots, right? So I'm just going to do 2. So that may see why I didn't put in +1? Because they said only x values less than. Less than 0 means negative, huh? Somebody said, how much in your bank account? Less than 0. That means negative. That means you're in debt, right? Right? You guys with me so far? So then, now what do you do? Just plug those in. I would just plug them in. I mean, you could do the whole slope thing. You might wonder, like, what, Mr. Aaron, why aren't you doing the slope thing and all that? Yeah, you could. I think it would confuse you. I think this, I'll show both ways maybe. I think this would be easier for you. So just plug in the 0, and that'd be what, 7? And then plug in the -1. That'd be what, 4? So I would just put those 2 dots on the graph and connect the dots. And then we got to do the other side too. So far, what am I getting? Over 0, up 7. That's 1, 2, 3, 4, 5, 6, 7 right there. That's the dot over 0, up 7. And back 1, up 4. Right there. And then it has to go that way. So everybody see it goes left, not right? Because that's the mistake I've seen a lot of people make over the years, is they'll start on this dot and they'll shoot to the right. But remember, he only goes less than 0, less than or equal to 0, right? Negative territory. He's got to remember, what zone is he in? What zone? He's only when x is less than or equal to 0. That's left. Okay, now, so that's the first piece. So I'm looking at, it's either A or B, huh? We already know it's either A or B. Those are the only two that have the correct left piece of line, don't they? A or B. C and D are crazy. So now, let's do the right piece. So if it's okay with you, I'll just erase this up here and do the other one now and add to the graph. So, come on up here and I'll say, okay, now I'm going to do this. And what does that tell me to do? Make an XY table again. And it's telling me y is 1/4 x plus 1. Now, yeah, if you want to, you could just do the slope thing. Like, I mean, where's that start? Where's that one's first point? At 1, right? You start up 1 in the middle. So that would be right here. But am I going to make that a solid dot? No, why not? Because it's only x greater than 0, not equal. It says greater. It doesn't say greater or equal. If I say, hey, I'm thinking of a number greater than 0, that means positive, doesn't it? Not 0 straight on. So what that means, do you know what that means on a graph? Open dot. That means you're really close to that point, but you don't quite make it all the way. Open dot. It's like hollow. It's like they drilled it out, right? They just drilled it right out. It's a hole right there. Doesn't quite make it all the way there. And then but it's like a dot. It's basically a dot. They just didn't quite make it all the way. We use it as a dot. And what's the other dot? Well, rise over run, huh? Go up 1 over 1, 2, 3, 4, and that one will be solid. And we go to the right because this is greater to the right. So there it is. Which graph's correct? A, B, C, or D? B is the right graph. Is that making sense?
How do you know if it's going to be a solid dot or?
Yeah, good question. Solid dot with the solid bar. So let me add to my little thing that's on the board there. Good question. Yeah, so solid bracket, solid bar, solid bracket, solid dot. They all go together because you're right on the thing. And these guys go with the hollow dot on that. Right? Because you're not equal. You're not right on the money. So you're not solid there. So solid bar, solid dot. And we see how on the first one here, this guy, we had a solid bar, so we had a solid dot. For the second one, no solid bar, no solid dot. Open. Is that good? Now, I did those lines 2 different ways. I don't know if you noticed. For the left one, I made a table. I plugged in a couple points. For the right one, I just said, hey, let's just do the, start at 1 and go to the right. Technically, you could do either. Both will work. But you don't want to be confused. Let me show you what I mean. Here's what I've seen people do. So that's the right answer right there. Let me show you what could happen. So it's fine. If you want to just do the slope intercept thing, that's fine, but don't make this mistake. Watch this. This is what I've seen over the years. People will go there and they'll go, oh, yeah, I know how to graph that. I don't need to do anything. Well, here, I'll make a little more room there. They'll come in and they'll go, okay, I know what to do. And they'll say, okay, where do we start? 7, right? That's correct. The number out there. 1, 2, 3, 4, 5, 6, 7. There's the first dot. And then the slope is 3, right? 3 over 1. So I'm out of room now, aren't I? That wasn't good. Okay. I come way down here, I guess. Up 1, 2, 3, 4, 5, 6, 7. So there's their first dot. Up 7, right? I'm graphing 3x plus 7. So I start at up 7. That's correct. There's nothing wrong with that. And then 3 over 1. That's your rise over your run. So go up 3 over 1. Right? I went up 3 over 1. Connect the dots. There we go. Well, what's wrong with that? You're only supposed to do that graph where? Less than 0 territory. So that's the right line, but this part should be erased. Because it only goes left. So as long as you do that, you're fine. Does that make sense? You've got to always remember the zone. He says only on the x-axis, here's 0, in this zone, less than 0. Left of 0, huh? Is that good? So just be careful that when you're all done, you get the right piece that they're asking you for. There's a tendency to think, well, that other dot's over here, I got to have that part. Well, no, you don't. And that other dot helped you, but in the end, he's not part of the deal. Only left of 0. Good? So you can do it that way as long as you're careful to take the right piece when you're done. That's kind of hard. Okay, yeah, I mean, you can do it. Yeah, just try it. So just go ahead and start making the graph. Yeah, let's just do it. Let's just do the slope thing. I think we should just do the slope thing. So go ahead and just take this one first. Where do you start with that one? -1, right? And then, up 2 over 1, rise and run. So get your line, get the whole line, and then when you're done, erase part of it, right? Keep only the part that's in the zone you need. Notice the zone. Piecewise. So, okay, so I will start at -1. So down 1, there's my first dot. Okay, and then where do I go from there? Yeah, 2 over 1. Let me bring it down over here. It's 2x minus 1. Yeah, 2 over 1, rise over run. So I go up 1, 2, go up 1, 2 over 1. You okay with that? Am I making sense? And then connect the dots. Good like that. Good so far. I haven't erased anything yet. I'm gonna. But generally okay so far, right? I just start it down with that outside number is always right in the middle line. Start down 1. And then from there go up 2 over 1. Connect the dots. Got our line. Now, what part do we really want to keep? Only x values. Now remember, this is the x. It's always the sideways axis they're talking about. Only x values less than x less than or equal to -2, huh? So where's that? Here's -1. Here's -2. We want here and left. All this is gone. You tracking with me? It's kind of weird, huh? Just that and down is all we want. Because that's the condition they gave. Less than or equal to -2. from -2 and less on the x-axis. Is it good so far? Now, can you graph the other one? The minus x plus 2? Can you put that one on the graph? Minus x plus 2? So I'm going to graph that one. Let me get this out of the way. So for that one, minus x plus 2, where do we start? At up 2. Huh? 1, 2, right there is our first dot at up 2. And then where do we go from there? Yeah, good job. There's really, it's -1/1 there, isn't it? When there's nothing in front of that x, just make it 1/1. And always put the negative sign on the top. You don't have to, but I think it'll be easier for you. It doesn't go on both. The only thing you could do that's really wrong is if you put the negative on both. That can't be, because 2 negatives would be positive, huh? That's not right. So I just stick the negative on the top, and that's rise over run. So that means from here, go down 1, over 1. Is that good? Connect the dots. Like that, but I don't keep all of that graph. What part of that graph do I keep? Only the part greater, right? That's the condition. If x is greater than -2. Greater than -2. Where's that? Well, that's right here. Here's the -2. It maybe help if you put in the -2 line. There's the -2 line. And you're to the right of that. So I keep the part greater. And that's an open, why is that one an open dot?
Because there's no bar.
Because there's no bar here, right? It's just greater. It's not greater than or equal. So you know which one has the open dot and the solid dot based on who has the bar. Right? Whoever has the bar has the solid bar, solid dot. So the one going, and you can tell that, yeah, the one going left, if you look up here, the one going left has the solid bar, that's this guy. The one going greater, right, has the open. There's our graph. Is that making sense? As we go back, let's see if it's easy to tell which one it is. Wait, which one? So it goes like down and then back. Can you tell? I'm going to go again. So there's our graph. Let's go back. I agree. See how that's the same thing there? That good? Is that making sense? Questions I can answer? Now they want domain, I just noticed. So they want domain. They're saying, what's the domain of the function? Now remember what we said domain was? Domain is if you walk around on the x-axis. Domain is how far left, how far right. Let me put that here. So domain is how far left does the graph go, how far right does the graph go. What do you think? Yeah, forever left. -infinity to regular infinity. Forever left, forever right. The domain goes forever left, forever right. Forever left, forever right. So the domain is -infinity, infinity. And there we go. We're done. Everybody good there? Questions on that one? All right. You got to give them the range also. So let's give them the range. We've got the domain. The range, remember the range is up and down, huh? How high, how low does the graph go? So just think about how high if you're a little person here, walking around on the y-axis, how high can you go, how low can you go, and you'll look over and see graph. That's what we're talking about. Bottom, comma, top. Bottom, comma, top. So how low does the graph go? How high does the graph go? What do you think? It goes down forever, huh? See, this piece is going down forever. There are two pieces. It's definitely going down forever. So the bottom is definitely negative infinity. Now you might say, well, yeah, but this part starts right here. Yeah, it does, but this covers all those values in between, doesn't it? So basically, the red graph is covering everything from whatever its top is down to negative infinity, all heights. So I just got to find what that top is right there.
4.
How do we know what that top is? Yeah, good question. Anybody have a good answer? 4? Think it's 4? Did I hear 4?
3.
Yeah, it's a little tricky, huh? I wonder if we can tell back in the picture. Since we know C is the answer. Yeah, let's just do that. Wait. Yeah, so there's our answer. Yeah, just take your answer. How about that? We know the answer C. Here's the answer. Everybody see what I'm doing there? I'm taking the answer C. You can blow it up, on your thing there. And so yeah. So the question is, how high up is this? Because that's the highest. That's the top. And the graph goes down to negative infinity. It's clearly the bottom, huh? So how high up is that top now? Well, careful. How much must each of those jumps be? They got to be going by 2s. Because if you count them off to 16, this is 16, 14, 12, 10, 8, 6, 4, 2, 0. See that? It goes up to a top of 4, doesn't it? You were right. See that? So the range, then, which is bottom, comma, top. The bottom is 4. The top is infinity. Parenthesis on both of them. Why? Because open dot, you don't hit it. That's what it means, right? The open dot goes with the parentheses, right? Because you don't quite hit it. You're not right on it. You get close to it. And, of course, infinity always gets a parenthesis because you're never on infinity. Hey, wait a minute. What did I do there? That's not the bottom. That's a crazy answer I'm writing. The bottom is not 4. What am I doing? What's the bottom? Negative infinity. The top is 4. There we go. There we go. Good for the range? The vertical coverage. All is well. Questions on that? Okay, so number 11. Try that one. So just take those functions one at a time and you can draw them. Okay, I'll jump in and help. So let's see here. Okay, so let's graph x plus 1 first off. So where's our first dot for that one? Yeah, up 1. We good right there? At up 1. And then what's the slope in the front of that x there? Just 1 over 1? Yeah, totally. 1 over 1. That's rise or run. So you go up 1 over 1. There's your other dot. Connect the dots. That good for the first one? Now we've got to erase part of it, of course, but okay so far? Just I started it up 1, because that's the number off to the right, and I went up 1 and right 1. Rise over run. Okay, now, which part am I supposed to keep? Well, it says only keep x values less than -1. So x-axis, here's -1, Here's +1, here's 0, here's 2, here's 3. Maybe it'll help you if you write in the x-axis, because we'll always end up talking about the x-axis, So there's the x-axis numbers, and they say only keep the zone, what? Less than, left of, -1, right? Lesser things are to the left, greater things are to the right, Left of -1. So that means get rid of all this. And do I do an open dot there or a solid dot at the -1? Yeah, no solid bar, so open dot right there at -1, We good so far? We can probably answer it right now. Oh, not quite. We have a couple options still. It could be, which ones are left in the mix? Well, a lot of them, I guess. Yeah, let's just keep going. Anyway, so now we got to get the right one. Is that okay so far? That makes sense how I'm doing that? Now do the right one. You guys are doing pre-calculus here. Now minus 2x plus 1. So where's our first dot? Up 1 again. All right, we start there. It's our starting dot. And then what do we do with the slope?
-2/1.
Yeah. Down 2 over 1, Down 1, 2 over 1. Right there. Connect the dots. And we're supposed to go all the way greater than or equal to -1. Anywhere right of negative. So you're supposed to go all the way back to here, actually, And stop right there. Because anywhere -1 or to the right on the x-axis. That's what it says. Solid dot, because it's greater than or equal to -1. Is that okay? Is that making sense? So I actually added to that line instead of subtracting some of them. How are we doing? Is the zone thing working out for you? So that the second line, the purple one, after I got the two dots and connected them, I looked and said, okay, what is the condition on x? Where is he supposed to exist? Greater than or equal to, which means right of -1. Everywhere right of -1, solid dot. So here's -1, everywhere there, right there, and to the right. Greater is right, less is left. Good, and solid dot, Solid, because solid bar equal to -1. All right, so which graph is it? They're kind of close. Is it D? What's wrong with B?
It's down at the -2.
What's that?
Is it down at the -2, not on the -1?
I don't know. I can't tell. It looks close. Yeah, I can see that A is not right because this open dot's supposed to be right on the axis, And this one's below it a little bit. See that? So that's not right. I agree with y'all. And I can see that C is not right. See how his open dot is below the axis also? See how my open dot's supposed to be right on the axis there? Okay. So B, it's either B or D. Yeah, it looks like D, doesn't it? Because that's only 2 above. It's only 1, 2. This is only 2 above. This looks like it's 3 above, doesn't it? Yeah. Right. Oh, wait a minute. Is it 3 above? Yeah, this is a tricky one. Yeah, sorry guys, it's D. It's B actually. All right, here's why. Here's why. Yeah, this is tricky. This is more tricky. Okay. Remember what? Let's go back to what did we do this? We started here and we went what? Down 2 over 1. Right? Because that was the slope. Down 2 over 1. So that means if you're going to back up, you got to go up 2 over 1. That does have to be up at 3. Do you see that? That's the steepness. That's the slope of him. I did kind of a poor job when I went backwards. I wasn't careful. Do you see that? You want me to show you that again? Right? Look, what's his slope? Every time you go over 1, you go down 2. Right? That's what his slope says. So this has got to be way up here at 3 to go down 2 over 1 and be at a height of 1. So at a height of 3, so it's B. See, that's at a height of 3 up there. You guys don't look too happy about that. Am I seeing? I know it's such a jumbled up mess now. See, then that probably didn't help. See, he's got 1, 2 over 1. Remember, that's what we did for his slope, because the slope is down 2 over 1. So if you do that backwards, I had to go back here to -1. I have to go up 2, back 1. So from 1 up 2 is up to 3. That's at a height of 3, isn't it? Because of his steepness. So it's the B. D is only at a height of 2. See how D's only, that dot's only up 2? And B's up 3. We good? That's a tough one. That one's such a mess now. Oh, yeah, I would just do domain and range from the, yeah, no, you can do that. 9, they're giving us, what are they giving us? See how it says g of x, or that's just y, is 2. Notice there's no x there. It's just 2. And that just means, and that's y, right? Y equals, the function values are y, g of x, h of x, whatever, that's just y. So y equals meaning height. That means the function's at a height of 2. So the function's up here at 1, 2. Well, I'm going to run out of room. I better make more room than that. The function's up here at height of 1, 2. At a height of 2, just flat 2. Whenever x is what? Less than -2. So -1, -2. So from here and to the left. So get rid of all that. There and left. Open dot, left. It's at a height of 2. And then it's at a height of 9. Way up to 9. 3, 4, 5, 6, 7, 8, 9. Greater than or equal to 92. So from here to the right, it's at a height of 9. How are we doing? And that's all you got to do. There's no x on those guys, so there's no slant. Right? It's just a height of 2 and a height of 9 in their different zones. Height of 2, height of 9 in their different zones. So which one is that? Yeah, because it's got the solid dot here and the open dot there, huh? Right? So just like we did before with the open solid dot. Right? The one that goes right, greater than is right, has the bar. The one at 9 has the bar. Oh. Has the bar, solid dot. Right? Is that okay? Questions I can answer? So that's the other 2 or 3 I was skipping. Those will be quick and easy. We did all the hardest ones. All right.